Okay, welcome to day 2 of the motherboard build for retro computers. Today we're going to be working on memory and CPU. The goal today is to show you the different kinds of memory that were used, how to install it, as well as what a Socket 7 CPU look like, and how to install it to get your machine up and running. So the first thing to talk about is the RAM. The RAM was a little bit different on these systems than you may have seen on more modern machines. This RAM, at least in this board, used 72-pin SIMMs, SIM standing for single inline memory module. And the SIMMs were smaller than your standard RAM you may have seen recently. They look like this. And let's just say a standard stick of RAM these days looks something like this. So as you can see, they're much smaller than the RAM we're using these days. Now these were usually came in the way it would work usually is most motherboards had either 2 slots or 4 slots for RAM. And the way the RAM would work is, as I said in last week's video, it had to go in pairs. So the memory increased in duplicate in how do I put this, in duplicates of 2, sort of powers of 2 rather, as it went up in how it would go into the system. So you would maybe start with 2 singles for 2 meg, then you go to 2 doubles for 4 meg, 2 4s for 8 meg, then 2 8s for 16 meg, 2 16s for 32 meg, 2 32s for 64 meg, so on and so forth. Most of these old motherboards usually had a maximum amount of memory of anywhere from 64 to 128 meg. And as I said, they always had to go in pairs. So the way these worked is these SIMMs were keyed on one side. They had like a little cutout on one side right here that would only allow you to put it in the slot in one direction. But the other strange thing about the way they worked is they always had to go up and had to go in at a 45-degree angle. And then you stood them up and they would lock into place. So there's clips on the board for each one of the RAM slots, here and here. And the way you would do it is you would take your memory, you would insert it, as I said, at a 45-degree angle. So you heard it kind of go in. Then, once it was in place, there we go, you stand it up, you'd hear a click, sometimes. Sort of a click, sort of a squish, depending on what kind of clips they were, and it would stay in place. So that would tell you it was installed correctly, and you would just keep installing the RAM modules until you had as much as you needed. So the trick was on the boards they were listed on the board. This board is listed as bank 0 and bank 1. So this would be bank 0 would be your first pair of sticks, bank 1 would be your second pair of sticks if you had a second pair of sticks, and you would put them in, as I said, at a 45-degree angle and stand them up. Now the other interesting thing was, if you look at the way the board is set up, bank 0, the first slot in bank 0 is at the farthest edge of the board. Now since this is the back of the board, we'll call this the left side of the board. Or the way it works is you couldn't slot a piece of RAM anywhere else before slotting one at the farthest edge of where you were going to install it, because if you did, you'd never be able to install another piece of RAM. And I say that because of the fact that if you tried to, say, install this stick of RAM, say, here instead, okay, let's just say for fun you want to install it here. Let's say we're going to populate bank 1 instead. And you say, well, I'll populate this slot first. Okay, once it was populated and we had the RAM in place, the next slot would be the one next to it on the left or the top. Well, there'd be no way to get another stick of RAM in at the angle you needed to get in at, which is for about 45 degrees, because this guy was already in the way. So you always had to install it so that you were at the leftmost or topmost, depending on how you wanted to look at it from the angle at which you were facing the board. You had to always make sure it was towards the farthest slot first. So in this case, bank 1, or we'll say bank 0, the leftmost slot will go in at an angle, stand up, lock in place. The next one, again, at an angle, lock it in, stand it up, that's it. Now they're both installed. Now this board also comes with a PC66 SRAM. stood for synchronous dynamic RAM, stick of memory as well. Now most of these boards didn't come with this one. This one's kind of bizarre. But if you were fortunate enough to find a board that has one of these slots in it, you can bypass not having to use the SIMs at all, which are they're kind of a pain. There's all kinds of little nuances about them you have to watch out for as far as how fast they are and so on and so forth. So what sometimes was easier was to just get one of these, like a stick of PC66 SRAM, like this one here. And what you would do is these slots were keyed, unlike these ones where they had an edge chopped off the actual stick of RAM. These ones were keyed with keys here, little notches in the RAM. And the way it would work is the RAM slot itself also was keyed as well. So you would just basically line up the keys with the RAM slots, slide it into place first, kind of get it in there before you're ready. So it was where it needed to be at. Then you push down real hard and it would slide and lock into place. And that was it. Now normally most of these boards wouldn't accept both types of RAM. So if you were going to use SRAM, you couldn't use SIMs and vice versa. That's kind of sort of how it went. But in a nutshell, that's how the RAM worked. It was bizarre. I'll never forget the first time I went to build a computer, I learned about this, and RAM back then was incredibly expensive. No one was running 128 meg of RAM, even if the board could support it, because about 32 meg of RAM back in those days was $1,000. No one was spending $1,000 in RAM. So 8, maybe 16 was your top end. I think I bought a couple of 4s back in late 95, and it's costing about $300 for 8 meg of RAM. Insane. Okay, on to processors. This is a standard socket 7 ZIF socket, and the way these sockets really work, it was relatively simple. Then an arm that would open up in order to install the processor, and then close to lock the processor into place. And the way they work usually is kind of push them off to one side, kind of pull them up. The entire socket would move off to the left, and you kind of feel them lock into place. Now, when you went to install a processor, most of these boards took up to about 166, 200 megahertz before they introduced the 233 megahertz Pentium. All of these were set up the same way. The processor itself had a grid of pins around the outside of it, but one of the corners was usually chopped off, like this one here. It's missing a pin or two in the very corner of the CPU, and it was only in one corner. So the rest of the corners here, here, and here were fine, but this one corner was missing a couple of pins, and it was angled. So what you would do is you'd look at the motherboard, look at the socket, and if you look here, we got a corner, a corner, a corner, and there's a chopped off corner. There's also an arrow pointing at this corner on the board. There's a silk screen arrow pointing at the corner of the board too, telling you that that's pin 1. So all you'd basically do is you just take the processor, okay, line it up with that corner, install it. It would just kind of fall into the pins like that. You push the arm back down, it would lock into place, and that'd be that. Your processor was installed. No big deal. Now most of these processors usually had to have at least heat sinks. That's what we had back then, which were basically passive cooling. It was a big, huge metal chunk of metal that had fins on it that would basically pull off heat away from the processor and disperse it elsewhere in the case. A little bit later on, we started getting fans with them as well, but initially it was just a heat sink. I got one here. They were all different, but the way they really worked is that if you look at the socket here, there were clips in the side of the socket. There's one here, one here, one here, one here, and these coolers were basically designed to go in those clips. You basically clip it onto one side like that, or maybe the other way, and they would sit right smack dab on top of the CPU itself, and you just push the other side down. It would clip into place like that, and that was it. And now when you turn the thing, you need a 4-pin MOX that would go into your power, that would power the fan. So the minute you turn the system on, the fan would start spinning, cool the CPU off, and you were good to go. These older processors did not require any kind of thermal paste. We didn't even have it back then. I don't think thermal paste was introduced until like the Pentium 3 slash AMD Athlon Duron era. There may have been some in the Pentium 2s, but the original Pentiums and anything before it, 46s, whatever, it was just passive cooling. So that's all you needed to do, and that was it. So that's processors, and we're going to wrap that up for today. Next week we'll move on to graphics and sound. Thanks for watching. We'll see you next week.